Hi, everyone. Thank you for joining. We're going to give people just a few more minutes to trickle in, and then we'll get started. And while we're waiting, I'm just going to launch a quick poll asking you to rate your proficiency with Kibana. So please feel free to go ahead and respond to that poll while we wait. And for those of you who just joined, we're going to get started at about 5 past. Just going to give folks a chance to join the webinar. In the meantime, there's a poll active where you can rate your proficiency with Kibana search. And we've got about 86% of you have voted so far. So please do continue to fill in results. Okay, I think we're going to go ahead and get started. We'll just kind of begin by sharing out these poll results so you can get a sense of kind of who your cohort is, who your fellow attendees are. We've got about 92% of you folks rating your proficiency with Kibana search at the beginner level, which is ideal since that's really what we're going to be targeting in terms of content today. And hopefully we can teach you something new and get you closer to that intermediate or advanced level. What I'm going to do now is share out my screen with you guys, and we'll spend a little bit of time talking about the agenda and reviewing Kibana search features and strategies, as well as how to actually apply those within Kibana with some hands-on examples. If you have any questions, please feel free to enter those into the chat, and we'll try to take care of them near the end of the session. So thank you and welcome to this Logz.io webinar on Kibana search. This is the first part of a two-part series focusing on basic and advanced search strategies, as well as techniques for creating visualizations. In addition to webinars like these, we also do offer self-service learning materials at the Logz.io Academy, which includes a number of different types of onboarding materials and tutorials, but also includes archived webinars such as these. So it is the case that you can always go there and review any webinars that we've recorded previously. I definitely recommend checking it out. It is included with any subscription that you have to Logz.io and is also open for trial customers. So you can go to academy.logz.io, set up an account, and access material like this on demand. I am your presenter. My name is Mike Neville O'Neill. I'm a senior customer success engineer at Logz.io. I represent the customer success organization. We are the driving force behind these webinars, and we're here to support both customers and prospective customers who are evaluating the solution. So if there's anything that you need in terms of technical questions or training, you can always reach out to us at help@Logz.io, and it's also the case that there is an in-app chat. You'll see that intercom icon, a little chat bubble in the lower right-hand area of the web UI, which you can use to get access to our support engineers who are available 24/7 by 365. So here's a pretty rough agenda for today. It's pretty simple. We'll talk a little bit about logging for success and the importance of structuring your data in a meaningful way or applying custom parsing. Then I'm going to talk a little bit about some different interrogation strategies you can use with your log data via Kibana in the Discover tab. And then we'll spend most of the session today actually doing some hands-on examples with some demo data that we have here at Logz.io. So I want to start by talking a little bit about logging for success and the importance of ensuring that your data is parsed properly. And that's true whether you're using a service like Logz.io or if you're running ELK yourself or hosted elsewhere. Really, data parsing is just the process of making unstructured data or text useful. It's the process of transforming a log event or text into a JSON document that can be indexed by Elasticsearch. The reason it's important to ensure your data is parsed is because it essentially makes it more valuable. You can easily display and filter data that's been broken out into discrete fields, and then once you have those fields parsed, you can apply aggregate functions to those fields in the forms of creating visualizations, and it's also going to give you the ability to set up and configure alerting, and that is a feature that's unique to Logz.io. So there's a few different ways you can approach kind of parsing your data and getting it into a format where you can run the types of searches that we're going to show off today. Of course, as you would expect, if you send in your events as JSON, that's automatically going to be parsed by Logz.io. So we'll always be able to parse the fields from that JSON, and it will ensure that the logs will be parsed properly, even if you change the format or the structure of that data on your side. It is also the case that we have a number of pre-configured parsers that we apply based on the type of log. I've linked to the documentation here, but all that process really entails is including a type field in your events. and then providing a value that corresponds to that type of data. So it could be Apache Access or Nginx or HA proxy, MySQL, or any other source that we have a predefined parser built out for. The third and final option, which tends to be the most popular, is what we refer to as parsing as a service. So I had mentioned before that you can get in touch with support via help@Logz.io, but also via that chat bubble. In addition to having the ability to ask them technical questions, you can also request that custom parsing be applied to your account. We actually have a transformation layer as part of our ingestion pipeline that allows us to manipulate data that you ship before it's indexed. So all you need to do is get in touch with support and let them know how you'd like your data to be parsed, and we'll take care of the rest. And that's included in your Logz.io subscription, free of charge. There's no limitation on that service. And if you are trialing the solution or you're on the community plan, definitely recommend you give that a shot as well, and our support team will be happy to help. So with that housekeeping out of the way in terms of the importance of ensuring that your data is parsed, I want to talk a little bit about some of the more common search strategies you'll be able to use in Kibana. The three here that you see are probably the most fundamental, and everything you'll see subsequently are variations on these search types. The first type is a free text search, which is a very Google-like approach to querying your data, where you're entering a term or a series of terms with no operators whatsoever. Just kind of stream of consciousness text that you'd like to get results for. So in the example here, the query is the quick brown fox jumps over the lazy dog, that classic elastic example. When you run these types of searches, they're very convenient because you don't need to really understand how the Lucene query language works. But as you would expect, it's going to be a little bit less performant because each and every field in each and every log event or document is being queried. And for similar reasons, you're essentially casting a very wide net. So you can expect the relevance of the results that are returned by these types of searches to typically be somewhat low. Free text searching can be a really great place to start if you're not familiar with your data set or you're not sure exactly what it is that you want to find. But typically after you've narrowed down that data set a little bit using a free text search, you'd probably want to use a field level or filter-based search to ensure that the quality or the relevancy of your results is as high as you can get it. Field level searching is more targeted, as you would expect. And what that entails is specifying a particular field from your document and then searching on a specific value for that field. It's going to be more performant or accurate because rather than searching every field across every document, you're actually including some criteria to narrow down where Kibana should be looking within a particular document for a value. So you can see the example here in that query. This assumes that you have a log event or document with fields fox and dog, and this query will return all relevant documents that contain the value of quick for the fox field and a value of lazy for the dog field. The last way that you can add, or rather work with your data in Kibana, at least from a basic search strategy perspective, is filters. So filters are a more visual way of interacting with your logs. They're pretty easy to work with, and they can be convenient in a number of use cases if you just need to quickly filter on a specific field and value. As you can see here, it's a conditional filter based on the fields in the logs. So the screenshot there shows you what that process looks like, where you'll select a field that's present in your data, choose an operator, and then specify a value. It's worth noting that filters are always additive. So if you're familiar with Boolean operators, you can think of each and every filter that you're adding as being joined with an AND operator. So it can be somewhat simplistic or limited in some scenarios if you need to use wildcards or regular expressions, for example. So that is going to cover it, at least for our slides. What I'd like to do now is actually jump into Logz.io and give you a sense of how you can apply some of these search strategies when you're actually working with your data. So what we're looking at right here is the Discover tab in Kibana. It's where we're going to spend almost all of our time during the webinar today. You'll notice that there's really a couple of different categories of features, at least in Logz.io. The first of which would be Kibana, where we'll be working today. And then there's also some additional features that Logz.io has added, which are present on the toolbar running across the top of the page that are a bit outside the scope of what we'll be covering today. But did just want to make that clear. I do want to give you a brief tour of the interface just to Discover in case it's something that you're relatively new to. I know we have a lot of beginners on the webinar today. So one of the first places that I'll start is with the time picker, which gives you the ability to specify the time range against which your query is run. I'll be using quick for the most part, but absolute can also be very useful if there's a specific static time range that you want to search against. In this case, I'm just going to back out that time frame to the last 4 hours so that we have a slightly more compelling data set to work with. Below the time picker, you'll see that we have the query bar here, which is where you'll enter your searches and run them against your log events or documents. And something I also like to highlight here is the Lucene syntax link, which I think is easy to overlook. As you may know, the query language that is underpinning Kibana, as well as Elasticsearch, is Apache Lucene. And that link in the query bar will take you directly to Elastic's documentation on how you can run queries against your data in Kibana. So if you're ever kind of stuck or you're looking for inspiration on the types of queries that you might be able to run, I definitely recommend having a look at this documentation. It's quite thorough and relatively easy to understand. So beneath the query bar, you'll see that there's actually a histogram. And what this is showing is a count of the number of events that have been ingested over the time frame that we have selected. So over the last 4 hours, Kibana is going to try to divide that up into roughly equal intervals because we've specified that that should be automatic. And that'll just show a count of those events over time. And as is typically the case with Kibana, this is fully interactive. So if you do see a spike in events, for example, that ends up being of interest to you, you can always click and drag over that histogram, and you'll see that the time frame there is going to be updated automatically for you. Over on the left-hand side of the page, you'll see a list of available fields. And this simply indicates the fields that have been indexed, and it only reflects the most recent 500 documents that have been ingested. So this is not an exhaustive list of the fields that are indexed in this particular Logz.io account, but it is a helpful kind of starting point, or it can give you a sample of the fields that are present in those top 500 documents. Below the histogram, you'll see what we refer to and what Elastic refers to as the document table. So something that I've been doing up to now is kind of using the terms log event and document interchangeably. I will probably continue to do so. But in the Elastic nomenclature, a JSON document is ultimately what ends up being indexed in Elasticsearch. So log events tend to have a one-to-one relationship with the JSON documents that are indexed. So I'll use those terms interchangeably. So the document table contains documents or log events, each of which can be expanded using this arrow to the left of the timestamp. And then here you'll see the various fields and the values that have been parsed out from the message field in this particular event. So that's kind of a quick tour of the interface. Let's actually start to get into running some searches. And what I'd like to begin with is the free text searching that we covered just a few minutes ago. So if you'll recall, that's going to be kind of a Google-like approach to querying your data, where maybe I'll just enter in a couple of terms, here, error, and query. And as I mentioned, here case is not relevant. Each and every field is being queried for the term error in this case. So as you can see, we're casting a very wide net, and there's not always going to be both terms present in all the results that are coming back. So maybe it's the case that I'm looking for something more specific. Maybe there's an error querying a database. So you notice we've got around 881 hits. And when I run that query, you'll see that we're going to get a much kind of wider set of results, at least if I back out the time frame here. And the reason for that is that in between each of these terms, there's an implicit OR operator. So you'll notice that when I add that OR operator in between the terms, that the hit count is probably not going to change very much, if at all. So it's good to be aware that when you're running a free text search, that if you need to search on an exact phrase, you'll want to wrap that in quotation marks. Otherwise, what's going to be happening is there's going to be an implicit OR present between each of your terms, and that's going to be casting a very wide net indeed, where any document that contains any one of these terms is going to come back in the result set, which is probably not what you want in most cases. So if there were a specific error that I wanted to search on, let's say in this case request processing failed, I would run the following search to capture just those events. And there you'll see we're actually getting the targeted results that we're looking for. So free text, as I said, can be a really useful starting point. You just have to be aware that there are some limitations that we've covered, and also a bit of a gotcha in the form of that implicit OR operator, which I think can be a little counterintuitive at first until you understand how it works and what's going on under the hood. So that will do it for free text searching. What I'd like to cover next is field-based searching. So if you'll recall, what field-based searching entails is running a search against a specific field or fields from your log events. So I'll take it as an example. This looks like either an Apache log or maybe ELB. So we'll take as an example our Apache access logs here, where we're leveraging that type field that I had discussed earlier. So we're applying that Apache access log parsing to these events out of the box, doing a bit of GeoIP enrichment as well. So in order to search just for my Apache access logs, the first thing that I'll do is enter the field name and then a colon. And this can also be an equal sign if that's easier. And we'll set that as equal to Apache access. And unsurprisingly, the relevant results are going to be returned there. Unlike free text searching, both the name of the field and the value that you're supplying for it need to match exactly what is present in your logs or in that result set. Free text searching is pretty forgiving, as you saw, where if I entered in lowercase error, it was also going to capture results that contained an uppercase error. That's not the case with field-based searching, where if you don't get the field name and its corresponding value exactly right, as you see here, we're not going to get any results. So it always pays to be very specific when you're running field-based searches, and also to be aware of what your data looks like when you're running those searches. So if you're not getting any results from a given query, you'll just want to make sure that you've written it in such a way that it's going to capture what's actually present in your log events. So field-based searching can be combined with Boolean operators, as you would expect. So Kibana does support the use of and, or, not, parentheses if you want to get more explicit about the order in which a query is executed. It is also the case that you can use regular expressions in some circumstances as long as they are delimited by forward slashes. For the most part, you won't be using regular expressions. If you find yourself using these regularly and you are a customer of Logz.io, please contact support or your account executive to see what we can do for you in terms of custom parsing, since a lot of regular expression use is typically consistent with data that hasn't been fully parsed out. So in this case, if I wanted to just join those two terms or use an AND operator, let's say I want to see all of my requests coming from Windows. Do the same thing here. and the relevant results are returned. Something that I do want to clarify a bit is about having to supply a specific value for a field-based search. It is true that it needs to match exactly what is present in the log events or the documents, but it is also the case that you can use some of the other operators here. For example, if you just wanted to capture everything from Apache or any type field that contains or begins with the term Apache, you can use a wildcard there, and that's perfectly valid. Or maybe it's the case that you wanted to pull in a couple of different types of logs. Now, what's interesting is you'll notice that this query still works, even though I haven't specified an operator, and that is, of course, because of that implicit or, which is automatically being inserted between those two terms. So here what this search is doing is looking for any documents that have either a value of Apache access or ELB for the type field. So there's a lot you can do with these field-based searches, even if you're not 100% sure what the value looks like for a given field, or maybe you want to return a series of results with slightly different values for a field that all have the same prefix. You have the ability to use some wildcards and some operators to achieve that. So that's field-based searching, which is pretty straightforward. What I'd like to cover next is filter-based searching. So filter-based searching is a visual way of applying conditional filters based on the contents or the fields that are in your documents. And there are actually 3 different places where you can create and add filters. The first of which is via the Add a Filter button here on the filter bar. Second, you can actually create positive or negative filters based on the values for the available fields that you see here. So you can click any one of these fields, and what Kibana will automatically provide for you is kind of a quick and dirty group by of that field, where you can see the top 5 results from the most recent 500 documents. So as you would expect, that's not going to be an exhaustive or comprehensive list of all the values for that field. But what you can do is click on Visualize, and Kibana is automatically going to give you an expanded view of all the values that are present for that field. So that can be useful if you have a sense of what field contains the information that you're looking for, but you're not sure what the values would look like. You can click on Visualize and have that very quickly broken out for you. By default, that's going to be limited to 20 results, but you can bump that up as needed if you needed to see additional results. So that's something that I do like to highlight, in addition to the ability that you have to create positive and negative filters based on the values for those fields. It's also the case that you can get some increased visibility into all of the values for a given field by using that Visualize button. Within the documents table, you do also have the ability to add filters or at that document level. And we can do that by expanding an individual log event or document. So let's just start a new search so we can start from scratch. And I'll expand an event here. And you'll notice that next to each field and its corresponding value, there are 4 different buttons. And each button corresponds to a different type of filter that you can create. So as an example, we'll just kind of start with this asterisk here, which filters for a field being present. So all this filter really does is require that a field exists in whatever log event is returned by the search. So you're not specifying a value one way or another. You're just requiring that the field be present in every log event that comes back as a search result. So let's say in this case, I want to make sure that everything that I'm searching has a request method or a verb. I'll go ahead and click on that asterisk, and you'll see that our filter bar is automatically going to be updated with that filter that we just created, which just requires that the verb field exists. We can mouse over that, and you can edit it to give it a friendly name. In this case, it's already pretty friendly, but we can go ahead and add some friendly text over that. It's also the case that you can pin these filters to the interface, which is really handy. Because what this means is once you have pinned this filter, as you navigate to other areas of the interface, that filter will persist. So if, for example, you're searching your logs in this Discover view, and then you find something particularly interesting after you've applied a series of filters, you might want to move over to a dashboard to get a different view into the trends that are related to your investigation. So let's, for example, go into a dashboard, and we probably have an Apache Access dashboard somewhere in this demo account. And you'll notice that that filter that I had applied previously is still going to be in place here when we're looking at this Apache Access dashboard. So that's something handy to be aware of, is that you can pin those filters to save yourself a bit of work as you're searching logs and kind of moving about the interface and working with visualizations. So in addition to the filter you can create that will require that a field be present in your results, it is also the case that you can customize the columns that appear in the document table. So by default, we will display the timestamp and the message fields, and you'll also see that under the selected fields over here. But the message field may not always be of significance to you. There are some log types that don't use a message field or have a very verbose message field. So seeing that in the document table might not be a real value add for you. In that case, what you can do is customize the way that the document table appears by using this column icon here, where if I'm looking at ELB logs, Elastic Load Balancer logs, for example, much like access logs, I'd be interested in seeing the request method, the backend response code, maybe the processing time, and the request path if I could find it. And you'll see that all of that is being added to the document table that we're looking at. And in this case, the message is kind of crowding the document table. I'm not really interested in seeing it. So I could just toggle it either from the document itself by using that column toggle, or you can just go to selected fields and remove it there. And now we've got a slightly cleaner view of those events. It's also worth noting that once you create this custom view, that what you've essentially done is created a series of ad hoc sort filters for the columns that you included. So I can click on any one of these fields, and we can change the sorting from ascending to descending order. And that gives you kind of a quick and easy way to do a bit of additional filtering once you have customized the view of the document table. It's good to be aware that this custom view won't persist across sessions. So if you do log out and come back in again, or even run a new search, all of the changes that you have made here will be lost. The best way to preserve those changes is by saving your search and then using it at a later date. So you can save your search using this Save button right above the query bar. Not feeling terribly creative, so we'll just give that a pretty standard name. And you'll notice that when I remove the filter, start up a new search, all of those customizations are going to revert, and we'll go back to seeing the timestamp of the message. If I want to access that search later on, I can always open it, run a search for it, and when we reapply it, you'll see that those customizations are back. This can be really useful for saving searches and adding them to a dashboard because you do have the ability to do that, and it can help you to visualize trends in your data while you're simultaneously looking at underlying log events. And having custom saved searches like this can be really useful for that purpose. I can show you a quick example of what that looks like in our app prod health dashboard, where you can see, for example, we have a series of visualizations that'll be covered a bit more in subsequent sessions. But what you see here in this log detail visualization is that it is in fact a saved search where each of these columns has been customized so that when you apply filters elsewhere in the visualization, you also have immediate access to the log events or the documents that are informing these other visualizations. So that's something to keep in mind for the column customization feature. It's not just something that you'll use when you're searching logs or running saved searches. It can also be a real, relatively easy way of increasing visibility to existing dashboards and making it easier to work with, so you don't have to jump between the dashboard view and the Discover view to see the underlying log events. So let's go ahead and do away with the changes that we made so far, and we'll talk about positive and negative filters next and how you can add those from the document table. So we'll go ahead and expand that. And I'm going to start with a positive filter, and this is usually what I will do when working with any data set. If I'm just starting to search and I'm going to be writing a search for the first time, the first thing I want to do is narrow it down by the type or the source. So in this case, I'm going to add a positive filter here, which is the plus sign and the magnifying glass. And what this is going to do is make sure that all the results that we get back from Kibana contain both the field and that specific value. So in this case, when we apply it, we're going to require that each and every log event that is returned by this search contains a type field with a value of ELB. And the process there is going to be identical to applying that exists filter. I can also give this a friendly name, in this case ELB. And you can create negative filters in a very similar process as well, where maybe hypothetically you're not interested in any log events that are coming from the city of Seattle. You can go ahead and create a negative filter using that magnifying glass with the minus sign, and you'll see that it's going to be a big red filter to indicate that it is negative, which you can always edit, and you can also kind of invert the filters at any time, where you can make these positive instead of negative. The other place where you can add those filters, as I mentioned, is via the available fields listing, where you can expand any one of these fields and then create a positive or negative filter for specific values. I'm not going to run through any examples of that because it's going to work identically to what we just did at the document level. But it is good to be aware of and can save you some time when you're trying to filter down to a specific subset of results. The last way that you can add a filter to your search is via the add a filter button here on the filter bar. And this actually does give you access to a couple of additional features which can be handy. You'll begin by clicking add a filter, and then the next step is to select a field against which to apply that filter. So in this case, I'm just going to search on country because that's what I want to filter on, and you'll see that I get some help here in the form of autocomplete, where GIP country name sounds good to me, and it can be helpful for kind of finding those fields that you might not be aware of. The next step is to choose an operator, and you are already familiar with is and is not. Those are the positive and negative filters that we've been working with up to now. We talked about exists in the form of that asterisk filter that we applied, and then does not exist works as you would expect, where what that will do is return any events where the field that you've specified is not present. But what I think this is actually most useful for is the is one of or is not one of operators, because they can save you some time if you're searching for multiple values. So let's say in this case that I want to include requests from a specific subset of countries and in more than one country. So United States, China, and Israel. And we'll go ahead and save that. And what we're doing here is just looking for any document that has any one of these values present for its GeoIP country name field. And you can do the same thing if you wanted to potentially exclude those terms. So I think that can be quite handy if there are multiple host names or countries or other unique identifiers that you want to use to filter results. It's usually easiest to just set up a filter for that purpose. An important point about these filters is that there really is no flexibility in terms of their operation. So what I mean by that is that you can't use things like regular expressions, wildcards, really any of the kind of operators that we've covered so far are not going to be available to you. For example, where you saw before, I was running that search for Apache with a wildcard. You'll notice that I'm probably not going to be able to get away with that. And in this case, it's not going to let me apply that filter. So that is something to be aware of. So for really simple use cases where you know the exact value for a field, I really like to start off with a visual filter since it's a lot easier than typing everything out each time you want to work with a given subset of filters. But there are a couple of limitations there in the form of the wildcards and other operators not being able to be used, and also the fact that they are all additive, as I mentioned before. So if I were to add a couple of different filters here, such as, but I also want to capture my ELB events, and I want to do that via filter. So here you'll notice no results are returned because we're essentially running a search for both of these joined with an AND operator. So if you need to use or some disjunctive logic, you'll want to use the query bar. And in fact, using a combination of field-based and filter-based searching is generally in alignment with our best practices. So that was everything that I was hoping to cover just from kind of a searching perspective for basic search strategies. We'll kind of save some of the other material for the next session on advanced search. But before we move into Q&A, I did want to launch a quick poll to get a sense of how you have typically been searching events up to now. And while you guys are doing that, I am going to go ahead and take a look at some of these questions and see what we can come up with. So hopefully you guys are seeing that poll. We're seeing a few votes trickle in, and I'll share the results of that once we've got a good majority of voters here. Got about 68% of our voters here, 71%. Probably close this out around 75%, start to get into questions. And we've got some good ones, so definitely consider sticking around. All right, looks good to me. Kind of a pretty healthy mix of different types of searches that people are using, which is not a huge surprise. It's not quite evenly distributed, but close enough. So it looks like a lot of you are using all of the above, and some of you kind of favor free text or filter-based searching, but there's not too many folks using field-based searches, which isn't terribly surprising since I don't think that's very obvious just from the interface, but hopefully you've seen some things today that might make that a little bit easier. What I'd like to do now is get into the questions that you guys have posed. And I just need to stop sharing out this poll. And we'll get into your questions. So I got a good question here about whether there is a way to search for all results that didn't respond with 200? And is it possible to search for that just in the message field? So the question that we're getting here from Vladimir is whether we can search on all events that have this particular value for the request, I would assume, that didn't respond with 200. And yep, we should be able to do that. You'd probably need to use wildcards, and it can get a little ugly with URLs. But let's just take as an example how it would work through this particular issue. The first thing that I'd want to do, because we're looking for Apache access logs exclusively, is I just want to set a filter on the type. So now I know I'm only working with Apache events. The next thing that I'm going to do is take a look at the request field, which is where those events are going to be present. And he also said that they had to be GET requests that did not result in a 200. So I'll do this kind of iteratively, where here I could create another filter for verb. And we'll set that is equal to GET. So now I'm looking at all of my GET requests in my Apache access logs. And then we want to look for any events that did not respond with 200. So that's easy enough. And that's going to whittle down our results even further. And you can see how heavily up to now I'm relying on filters to do most of the heavy lifting. But the interesting part has to do with trying to get something that has a variable value within a URL path, for example. So here the ID probably changes. Let's take a look and see if I can find an actual result of this. Yep, where you can see that there's a different ID here that's probably going to be different every time. So there's a couple of ways that you can approach it. Obviously, if you wanted to search for that exact value, we could wrap it in quotation marks, but it's also the case that you could use a wildcard. So let's go ahead and go that route, where what I want to do is search on the specific request field. And then here you do have to escape the forward slashes, so it gets a little bit ugly, since the forward slashes are technically reserved characters that are used to delimit regular expressions. And then what I'd probably do here is just insert a wildcard. So you could do this in a couple of different ways. If you just have no idea what the ID looks like, and I'm actually just going to check to make sure whether I got this right, period. But you can see I'm going to pick up everything that begins with items, games, and if I didn't know how long the item ID was, for example, I could just throw an asterisk here, but maybe it's always 4 digits, and that's something that you're aware of. You can also use question marks for substituting individual characters rather than a wildcard, which will just grab everything. So hopefully that addresses your question, Vladimir. And hopefully you guys got something useful out there as well, since that's a really common request, is trying to figure out how you can search for sort of specific request paths that contain a variable of some type. And then also there was a question about kind of whether we can do use greater than or equal to operators. And you can. This is something that you'll probably end up getting into more next week. But it is possible to use range queries, and you can do that using braces or curly braces. So kind of a classic example would be the response code that we have to work with, where let's say that you're only interested in seeing your client errors. So what I would do here is 400 to 499, and you'll see that I'm wrapping that range in braces. And then here, 2 functions as an operator, where what we're doing is defining an inclusive range of any value for response that's between 400 and 499. This will work with numerical values, as you can see here, but you can also apply it to strings, where if you have a series of strings that you're applying a range query to, it'll try to order those alphabetically. You can also define an exclusive range using a curly brace, where this is actually identical to the search that I just ran. The only difference is we've got 500 here, but it's only going to return results with a value of 400 to 499. And you can mix and match, as I've done here, or I could make both of these an exclusive range. You also don't necessarily need to know where your range starts or ends. So if I just want to get everything 400 and up, I could go ahead and throw an asterisk at the end of that range. And the same would be true for the beginning, where maybe I just want to capture everything. So range queries can be really handy, obviously, when working with numerical values, and that's how you can potentially get to some of that greater than or equal to comparison. And that question was from William. Will we share a recording? Yes, absolutely. We will distribute a recording of the webinar, as well as the deck that I ran through at the beginning. And then there was a final question about whether we support ingesting from network equipment like routers and switches. Yes, we do. There's a couple of different ways you can accomplish that, which are typically via FileBeat or our syslog. So you'll see that we do have, I think, in applications. Let me go ahead and just pull this up for you. But for our networking appliances, for example, we do have the ability to forward events from that device to our syslog or to FileBeat. And what they'll do is prepend a shipping token to those events and then route them to Logz.io. So very common for our customers to use these options when they're shipping data from networking or security appliances such as firewalls, routers, switches, etc. Okay, I think that will probably do it, at least for the Q&A and for the webinar today. Really appreciate you guys taking the time to attend. There are some other resources that are available for you by way of our blog, complete elk guide. We do have a free trial, so if you're not using Logz.io today, you can sign up on our website. There's no credit card that you need to provide, and that'll give you a 14-day trial with access to all the features. And we also invite you and encourage you to visit the Logz.io Academy as well as our docs page. So thank you again for taking the time to attend today, and we look forward to seeing you next week, where we're going to cover part 2 of Kibana Search. Thanks again. Have a good day.